Alcohols are classified into several categories based on their structure and properties. Here are some common classes of alcohols. 1. Primary alcohols have one alkyl group attached to the hydroxyl group. Examples: methanol, ethanol. 2. Secondary alcohols have two alkyl groups attached to the hydroxyl group. Example: isopropanol. 3. Tertiary alcohols have three alkyl groups attached to the hydroxyl group. Example: tert-butanol. Allylic alcohols have a hydroxyl group attached to an allylic carbon. Example: allyl alcohol. Benzylic alcohols have a hydroxyl group attached to a benzylic carbon. Example: benzyl alcohol. Aromatic alcohols have a hydroxyl group attached to an aromatic ring. Examples: phenol. Fatty alcohols, long-chain alcohols derived from fatty acids. Example: cetyl alcohol. Sugar alcohols derived from sugars and have a hydroxyl group attached. Examples: sorbitol, xylitol. These classes of alcohols have different properties, reactivity, and uses in various industries such as pharmaceuticals, cosmetics, and fuels. In this experiment, you will be able to identify for the presence of primary, secondary, or tertiary alcohols in different samples. Acetyl chloride test. This test helps to detect the presence of an alcohol in a sample, but it does not show the class to which the alcohol belongs, whether primary, secondary, or tertiary. If the substance is alcoholic, the addition of acetyl chloride will cause the evolution of heat and release of hydrochloric acid, which can be confirmed when passed through ammonia gas solution, forming white dense fumes of ammonium chloride. Lucas test. The Lucas test involves the use of Lucas reagent, which is a mixture of hydrochloric acid and zinc chloride. This test is used to differentiate between primary, secondary, and tertiary alcohols, unlike the acetyl chloride test. The presence of an alcohol is noted by the formation of an insoluble second layer in the system. Primary alcohols form a clear solution when Lucas reagent is treated. Secondary alcohols react slowly by forming delayed cloudiness on treatment with the Lucas reagent. Tertiary alcohols, benzylic or allylic alcohols, form immediate cloudiness on treatment with the Lucas reagent. Chromic acid test. This test is also known as the Jones oxidation test. It is employed to differentiate between primary and secondary alcohols from tertiary alcohols. Chromic acid is added to the alcohol sample. The alcohol is oxidized by the chromic acid while the alcohol reduces the chromate 6, orange, to chromate 3, green or blue-green, resulting in the formation of a carboxylic acid and water. The reaction is accompanied by a color change. For primary alcohols, the solution turns green or blue-green due to the formation of an aldehyde. For secondary alcohols, the solution turns yellow or orange due to the formation of a ketone. For tertiary alcohols, no color change is observed as the tertiary alcohols do not react.